I'm Dan Sweeney from MathSpec Incorporated. In this video I'd like to go through two new worksheets that we've added to the Excel add-in. The first one is a summary page with filters for each of the parameters. The second is a high-resolution isotope worksheet. In this video I'm going to use some data from a compound called sulfathiazole. The data was obtained from two different sources. For the isotope data, I took the molecular ion and the associated isotope peaks from the NIST webbook spectrum of sulfathiazole. For the fragmentation data, I used two different negative ion fragmentation spectra from MassBank. To start the analysis, I'm going to bring up Excel and click on Add-ins and bring up the data input page. I'll add the isotope data first. This is a low energy MS spectrum. And secondly, a high energy fragmentation spectrum. And you can combine as many spectra as you want. Now, one of them, and the reason I have two, is that this one has good fragmentation but no deprotonated molecule or molecular ion, if you will. So by combining them, I can get at least 2% of the precursor ion. This is negative ion data. I'm going to clear the contents of this cell so the elemental formula is pretty much wide open. For the parameters, I'm going to use 4, 9, and 0, which are the default parameters. So now I'm going to hit transform. The EI spectrum at the region of the molecular ion was pretty weak, so it's very likely that these intensities are not very accurate. So I'm going to increase the error bars on the isotope ratio. It's now generating the partitions. Four partitions were found, and I'll go through them quickly here. This is a different formula than what was in the first two, and then this one has three different formulas possible. The partition scores range from 37, 49, and then the first two are both 64. And the isotope ratios are, in general, not very close. If we look at partition 4, there are three different formulas, and they vary on the 99 subfragment. So if we look at these three numbers, we have to kind of visualize them one at a time, that it could be this, this, or this. With the summary page, it's basically all the possible formulas for the three subfragments. In this case, they all had three subfragments. And a summary of all the possible formulas. And these are just the assigned fragment ions. One of the first things I like to do is look at the overall scores and pick out a couple of the better ones. Now in this case, the two highest overall scores all had the same molecular formula, so this is most likely the correct formula. I can now clear this filter and choose that formula that was the highest scoring one, and see if there are other partitions. So yes, there is a third partition now also comes up. It had a lower overall score, but these are all the partitions that corresponded to this formula, and they all have about the same formulas except for the number of hydrogens, and that's very typical of the partitioning process, that the heavy atoms will relate really well to the molecule, but the hydrogens are more mobile. I can also just choose the deprotonated molecule. In this case, it's been neutralized by the addition of a proton, and then this is the this is getting rid of the fragment assignments, and it's a little cleaner to look at. So basically it looks like the molecule, if we go here, is basically three pieces with these formulas, or plus or minus some hydrogens, and this is one possible alignment, and here's another. So we can't really tell whether the aromatic part here or the sulfur dioxide or the containing piece is in the middle, and that's typical of sulfonamides, that the SO2 can sometimes be extruded from the middle. Going back to the summary page, I can now take that formula and I copied it, and I'm going to paste it in to the isotope sheet, into cell A8, enter a formula in cell A8. Now this will calculate for 10 million molecules how many would be expected to have all the lowest isotope weight with 1 N15 or 1 S33, etc. And for example, there's only 1 out of 10 million molecules that we would expect to have 2 O17s, and the rest have the lower mass isotope. This is the distribution we would get. Now C13 on the first isotope is a prominent isotope, and you can see the other like the S33 and the N15, they're pushing up the front a little bit. These are sums, but it's hard to see that there's much discrimination of the isotopes. In the case of the second isotope, there's a pronounced tail on the end. So this is at the default resolution, which is 30,000. Now if I go up to 200,000 and reanalyze it, now there's much better resolution of the isotopes. It's also possible to format the axis. If we make it, let's say, take 2 zeros out, make it 100 times bigger, and now we can see the molecules with 1 C13 and 1 nitrogen 15 are the red piece in here, and we can get the exact location of those from the table above. Now the isotope sheet, worksheet, is independent of the data input in the partitioning process, so you can open the Excel add-in and just calculate out the isotopes if you wish. It's connected from the sense that if you, in your data input sheet, if you make it negative ions, then this will automatically start at negative ion. To take out, if you're going to reanalyze, you have to take out the filters. So it'll erase the old data before new data is put in. So that's a basic process by which you can use these two new worksheets.